Now, this whole subject of normalization, I know, can get very boring and can get very confusing if you're new to database design. And even if you've been around it a while, it can kind of get fuzzy sometimes. A couple of things I want to point out in this video. There are times when you want to normalize a database all the way out to the nth degree. Then there are other times when you may want to what's called denormalize, or in other words, not push every individual item out to its own separate table for various reasons. Usually we will denormalize so that we can query a little easier on some of our data. But I want to show you one of the basic benefits, two of the basic benefits, I guess, of normalization just in this real simple little animation. Let's start off with a table that we have that is storing the first names of some people and the status, whether they have been certified or not. Now, this is not a good real-world example because you'd probably never store just first names, but go with me here, okay? We can tell by looking at this table that Bob, who has an ID of 33, has been certified, and Jack, with an ID of 37, has been certified. Now, Janet, Allison, and Fred have not been certified, and I want you to notice something, that if we follow this same percentage of people being certified, we've got 5 people here. So 2 have been certified, so that means that comes out to 20% have been certified, 3 have not. So if we go to 1,000,000 rows, we're going to have 200,000 people certified, 800,000 not certified, and we will store 800,000 empty rows of data right here in the status column. That's not a good idea. Also, let's talk about what happens when we try to edit this table. Let me bring my yellow arrow back up again. Let's say that one user connects to this table and begins to do an update, and they're going to change Bob. Let's say they misspelled Bob somehow. Maybe he has 2 B's on the end, okay, or B-O-B-B-Y, maybe that's it. And at the same time, another user connects and needs to change Bob's certified status. It turns out Bob is not certified. He hadn't met all the criteria, whatever. Here's the problem. Since both users are trying to manipulate the same row in the table, one of them is going to get locked out. The database is going to make one stop and wait and not be able to perform their actions until the other one, whoever got there first, completes their action. So you're going to experience slow response, a database lock. The second person will have to sit and wait. Well, if we normalize this table and push the certification out into a certified table, notice we're going to take the common column, which is ID, we're going to put that column in both tables, and then we're only going to store the records for the people who have been certified. And so now, notice we only have a record out here for number 33, which was Bob, and number 37, which is Jack. Now, the big thing that this gets us is that if somebody tries to update Bob's name at the same time that someone needs to update Bob's status, they can do it because those records are now in 2 separate tables and it will not create database locking. So right there we have made inserts and manipulations much faster, much more effective in our databases. We've also made storage a lot more efficient, because we're not storing empty space on Janet, Allison, and Fred anymore. We're only storing data that applies to the appropriate people in this table. Now, there are going to be times that you will see people want to denormalize, and this is a good example of that. If I query this information quite a bit, let's say if this is one of the main things that I do with my company is provide this certified status information to people, then this is always going to be a join query, and I have to join these 2 tables. Well, it would be a lot more efficient if all of this data was back in one table. So for the purpose of getting my data out a lot faster, if I query this data much more often than I update it, then I may want to denormalize this, take the little hit on storage, but it's much easier to query the data out of here. So one of the things that you will see database designers do, especially when they work in groups, is argue and fight about whether to normalize or denormalize certain portions of the database. Every database designer is going to see it a little bit differently. There's not necessarily a right or wrong. It depends on who you ask. There's just a number of different ways to put this together and make it happen. But you generally want to base this off of how is the data being used. Are we updating it quite a bit? If there's quite a few updates and changes, then we want to normalize as far as we can. If this database is primarily used for query support to select data and provide reports, then we probably want to denormalize a little more. But that's the real benefits of normalization, and this is why we're going through this whole exercise, to make our data storage more efficient and to make it easier and faster to update our data. Because predominantly we're working, especially in this class, with OLTP, or Online Transaction Processing databases, which the reason we have these databases is to provide a way to store data and manipulate it very quickly and easily.